Uh, Welcome everybody. This is the last day of ESUG, so let's have fun. I want to start my presentation. It's about Roassal, the graphical software that I use in part of Faro to draw many different kinds of visualization. So a little bit of background. I am Milton Mamani. I am software engineer. I work in India with the team of Steph in Lille. This is my email address if you want to contact me. I am from Bolivia, and yes. So let's start. What is Roassal? It's a tool to visualize data. Okay, it's a tool to create data. It was created by Alexander Vergel. We have Alex here, so it's pretty cool. He created also this pretty cool book about agile visualization. But also it's a work of a lot of people that have contributed to this project for several years, like Martin Diaz, like Tudor, like Jura Kubelka, many names, right, that I cannot say it because I don't remember, but yeah, they were very important. And we have this repository, so you can see that it's open source, it's MIT, you can go there, contribute it, change whatever you want, and we have the CI that is going to validate if the change is correct. And as you can see, it has many starts. That is pretty cool in a project. And we have many forks also. So, and okay, and also Roassal is based on Cairo graphics. That is the low-level library that we use to draw things in the image. So, in a nutshell, what is data visualization? You have data, raw data like that, and you have to process it in the image. And then you have to arrange it. And luckily with that, you are going to explain something, a history about what you want to see. As you can see, it's pretty cool to have visualizations because you can find patterns. You can find visual patterns. And also, the same object can have different presentations, different visualizations of the same. About patterns that I told you before, we have, for example, this data visualization about football. So we have Lionel Messi that he's a striker, and you can see I take some of the values of the metrics of Lionel, and with that I draw a shape. And then I take another football player, it's Claudio Bravo, and he's a goalkeeper. And if you compare with the graphic of Cristiano Ronaldo, you can find that the shape of these strikers is different from the goalkeeper. And well, we use that to analyze football players in a small example that we have for Roassal. So okay, this is now a live demo, so I will try to write a demo. Oh no, internet, I will disable my internet. Okay, new one, I need just this part. Okay, here I have packages from Roassal, and I want to visualize these packages. So here's I create a canvas. Oh, that, and I can create some shapes. Usually it's like that. You have to create shapes, and you can put these shapes in the canvas. Collect. And here we need some shapes. Class shapes probably is better name. Define net classes. We close this thing. So I'm going to create small boxes, no ellipses, better. Model. Size. Yeah, that should be enough. But I can put some interactions like pop-up, probably. This is only, as you can see, just for one class. And then class shapes 2. Now I have a shape. The model is a class. Is test case if true. Yeah, something like that. And now I want to convert all this group. No, but I need the layout first. So I want to use grid layout on classes or class shapes. Yeah. And now I can convert this in a new shape. All this group can be a shape with this method. And the model for this one is going to be the package. And I can put some padding. And yeah, you know, I also want border with border color black, and also for this one. Return to the padding, I'm going to use 5 border color black. Yes. Now I have this thing, and I can use a pop-up yourself. Looks good. And then I have a group of shape packages. So I can put, for example, grid layout on canvas nodes. Finally, the canvas with some interactions. Canvas controller, just so I can manage the canvas. And I have first error. And I need here as a right probably. And I do not have nothing because I have the shapes, but I didn't add it. Canvas, add all shapes. Yes, I can see something. I would like to move it. But I don't like this layout, so I can use another layout. So canvas, rs, I want some animation, so I'm going to use force stepping interaction. This puts some animation in the nodes. Yes. Now you can see we have this thing, and because we have the model, we can talk with the object. So this is the package, and this is the class, and it works well, and I don't know how much time it takes it. But yeah, this is the idea. You have an idea of how to create a visualization, and you can create it really fast. Yeah, but you need to know what classes you can use, like these layouts and these interactions and all the stuff that you can do. But in general, it's pretty simple to create a visualization of any kind of objects. So, returning to my presentation. There are many things like the animations and noises. This kind of visualization was generated with a Smalltalk Faro. These are small videos about what you can do technically when you create new animations or anything that you want, because the visualization itself allows you to export in different formats like PNG, SVG, or or even videos. Yes, and then you can do crazy experiments that we did before with Domenico, that he's not here. Or you can create small video games with that. We did this with Alexandre to test the AI, the project AI he did. And also, yes, like these small examples. So technically, there is no limit. The limit is the imagination that you can use Roassal to generate whatever kind of visualization you want. Yes. Yes, yes. All the visualizations you are going to see were created with Roassal. So I'm not using any even for Google Maps, I don't use Google Maps, I am using the Roassal code. So, okay, that's what that we have, and I want to talk about now the new features that we have in Roassal. So, as we started for charts, this is a small example of the chart. We have a lot of data, different numbers from different groups that we have tested for day 1, day 2, day 3. And in order to visualize this data in Roassal, in the last release, you have to do a chart, then you have to create a plot. As you can see, you cannot select the lines, but from line 19 to line 21, you can see that we have to configure the box plot, sorry. And then from line 31 to line 33, we have to add this to the canvas, and then we can put some interactions some decorations in the canvas. And finally, you are going to have something like this. But we say, okay, this is too long. We can do it better. So now this is kind of the new API. So you create some plots, and then with the plus operator, you can combine them, and you are going to have the same, or kind of the same visualization about box plot. We have the new density plot that allow us to see the frequency of uses of some data. It's similar like you go to the gym and find this density plot about what is the most element used. In other ways, it's similar to histogram plot. As you can see, I take the same data and I compare it with the histogram and the density plot. You can see with this, you can have different information about what is happening with your data. And then we have the box plot. For people that does not know the box plot, it's pretty cool because this allows us to see what is the distribution of your data in fast way. So for the first group, as you can see, we have these numbers. And because we have these numbers, the box is not it's very normal box. But then we have this other group, and you can see that we have in this group the number 12. And you can see now also in the visualization we have a little ellipse. This is the outlier. So technically it's a data that is out of the group. So you can see that in the visualization, and this is pretty cool. And also the middle line in the box, I cannot point it, but it's the average of the data. So you can see the average of the medium of that. And then, yes, for the other box, we have this data, but it's well distributed. There is no information outside of this group. With the same idea, we combine them. We have the box plot and the density plot combined in violin plot. So now you can see in the same way that the density plot, in this case the violin plot, allow us to see where is the most common data. So if you see these big density areas, you can see that we have the objects in this, or the numbers in this area. And then also we have now the possibility to only work with plots, and by default values we are going to have these kind of plots. So you can see we have the line plot, and we can use some format. And the idea is to write less, and you can have something powerful. But also, if you want to customize any part of the visualization, you can do it, because each part of this is an object. So technically, here you can change whatever you want, and also you can add other elements that you think that you need for the visualization. And then we have the combined plot. Yes, in this example, it's kind of simple. I use a histogram, I use a density plot, I use a line plot, and then at the end, line 15, I use the combination of the line plot and the histogram. And the result is this visualization. Also, as you can see, yes, we have the cluster plot. That means that we can have groups of plots like that. You can see at the beginning we have one bar plot, another bar plot, but when we combine them, they find the correct position, so they are going to be in the correct group. So you can compare one plot with the other plot. And then also, we don't want to reinvent the wheel. Kevin, the student volunteer that worked in this project, he created the invert coordinates. So we can technically have horizontal plots for any plot that we have. So many thanks for Kevin Cespedes and for Paul, also an intern in INRIA that work in this project. And now for layouts, yes, we have more documentation and more examples. It's pretty hard to show that in a presentation, but I have been working a lot to put more tests and documentation so you can use different kinds of layouts we have. And also, I have been working in this tool. It's a layout studio. The idea is similar like the pyramid software, that you have an object and you can start to manipulate the properties of this object. So in this case, I have a layout, as you can see, and then the fields change, and then I can change with the user interface the properties of the layout, and with that you can see how this affects to the visualization, and then later, if you want, you can save this information, or you can load another layout, and you can see how it's going to perform with your data or with your visualization. Also, I implemented the OpenStreetMap support for Roassal. We have this in Roassal2, but we didn't have in Roassal3, so I ported it, and now it works nicer, I will say. So you can put the map, but also you can put some other visualizations based on the longitude and latitude of the map coordinates. And then we have a new selection that we work with Sofian, and he's here. He helped me a lot with this kind of projects. So technically you can select different objects in the visualization, and or you can do Command Alt to select them all, or you can remove the selection, or you can use the search. In this case, it's a basic search, but we want to increase the search in Roassal, so you can find the objects based on model in many ways. And then we have also this port that we did with Martin Diaz about generating block elements from Roassal. So it's the same idea. We have the Roassal code here, but I use block host, and now this is a window in block. So we have now violin plots in block. You only have to use that. And then the last thing is the escalation problem. Because we talk about with many people about this, but I'm going to talk about right now. We have this visualization provided by Hernan Diaz, And Hernan told me, I want to visualize the DNA of a bacteria. And we have this amount of elements in Roassal, and we have 144K elements. But the initial idea with Roassal was that we don't want to work with this amount of data. So we use, but we tried, okay? So you see, yes, I'm moving the mouse, and I want to interact with the visualization, but the problem is, yeah, it's not working. We have many elements to compute, it's not working. And at that point, I was like, oh, no. Yes, yes. You know, these kind of things, frustrated. So we had to understand why, and it's kind of easy because we are using a linear collection. So each time that we are going to find a new object, we have to do this kind of search in the collection. And when you have this amount of elements, it really take time. So as an I was kid, my biggest dream has to have more FPS in Roassal. Okay. So yes, I put some RGB in Roassal. So yes, because it's, yeah, everyone knows that if you put some RGB, you are going to have more FPS in visualizations in general. No. The general idea is that you are going to have, you need trees because trees are the solutions for everything. So we started with the quad tree because in the Spring layout that you saw before, we use this data structure, and it works well when you want to search different elements. And I implemented the quad tree in Roassal, so you can see this visualization that we did with Sebastian Jordan. When we take a character from a video, we separate the character and we put the character in the quad tree in Roassal to see how it's going to perform. So you can see the big blue squares are nodes that we don't have information, but the small blue squares are nodes that we have information. So as you can see, it performs well. Yeah, we did this with all the nodes. But the problem with this is the overlapping, because in Roassal we have these nodes that can be on top of others, and the quad tree does not work with rectangles, work with points. So I have to read this book, the Multidimensional and Metric Data Structures. It's like a Bible, a compendium of different data structures. Thanks, Steph, for that. and start to develop the AVL tree and work with some rotations. Why I'm talking about AVL? Because when you build this kind of trees, it's really important that you have a balanced tree. If not, you are going to have at the end a linked list, and you are going to have again a linear search, and we don't want that. We want to avoid these kind of things. So we have the rotation, and finally we have the air tree in Roassal. So the general idea is that you have a big rectangle that contains all the points of the visualization, and then the rectangle starts to split until at the end you can see that we have things like that, small areas of the rectangles. So the search should be faster, and you can see this is the structure. We have the branch, the main branch are empty nodes without any information, and the leaves of the tree are the part where we have the shapes. So I compared then this the speed when you add new shapes versus the list. So this is the results. So you can see we have the list in blue and the tree in I don't know this color in English, but you know, the tree. So you can see this is the difference between the list and the tree when you are going to draw one frame. But in this case, I draw in all the whole visualization, okay? It's not only one section, it's all the whole visualization. That's why the list and the tree are kind of similar in speed. And then I have when I move the mouse over visualization, and you can see the difference. It's really hard to see this, so I changed the scale, And this is log scale, something that we work also with Sebastian. And yeah, now we can see a little bit. In many cases, yeah, the speed is another word. And this is the final result. So I hope I don't want to destroy my machine in front of you. So yes, this is the visualization, but I don't want to pass the mouse because okay, now it works. It works. Yeah, you see, you can drag. Of course, when you have a lot of information, it's going to take more time. But now it does not freeze the machine. And this is pretty cool. I am really happy about the result because now we can navigate into big data visualizations. And this is pretty cool. Okay, so there are to-dos. Charts is not finished. We are not a big group to do a lot of charts that we have in different language or different data engines like Matplotlib and ggplot. But we want to have these charts because when we create data visualizations, we don't want to export that to different objects and work with different language. No, we want to have all this in the same Smalltalk image. So we can have a little bit of control of what we have in the visualization. And then we have the problem that we can work in dirty areas. For Roassal, I want more FPS. There are many ideas that we can have, using the GPU for visualization, using all the cores of the CPU, using caches like Martin Diaz work for block. But well, we have to synchronize because if they have that in block, probably Roassal can use that. I don't know. There is and again the idea, the integration that we can migrate or port or use Roassal visualizations with block, and that should not be so complicated for the users at the end. And there are other Roassal issues that I didn't take about, but all is in the repository. I want to close that before my next job for the next year. And yes, that was my presentation. I'm Milton Mamani from Bolivia. I have a 2 years contract. It's going to finish at the end of this year. And if you want to contact me, this is my email address, and all the visualizations and things that you saw in this presentation are here in this GitHub repository, so you can test it and try it. And yes, that's all. Thank you very much. Any question? Yes, Nuri. I don't know if we need the microphone. Why?
Try to speak loud.
Okay.
Yes, my question is about all the cool animation you showed. It's in Faro, and you showed us yesterday. Shows your project. You have the exports in the build on GitHub Actions.
Mm-hmm.
So what is can you expand on exporting? What formats you support? What's available? Any new update in this regard?
Okay, if I understood the question is what kind of different exporters we have in Roassal, right?
Right.
Okay, we have the PNG, PDF, SVG, and video. Yeah, we have only 4. I would like to have something that can convert that in JavaScript code. So probably we can work together really to have a Roassal plus Faro.js. Will be nice.
Have an interactive view.
Yeah, exactly. Yes. Another question? Yes, Alex.
Very cool foundation. Yeah. I'm just wondering, like, whether like the trees, like the AVL, is it like the default?
No. You have to implement it. There is no AVL. Well, there is now because I put it, but there wasn't AVL in Faro.
But I know, but like, is it the default Roassal. So if I start the latest version of Roassal and to have this AVL.
Okay, the question is if we have the AVL and these data structures in Roassal. The answer is yes, you have it in master, but I want to create a release of that, so it's going to be available in Faro 12. So at the end, you only have to use R3, and you are going to use the R3. I don't know if it's a good idea to change from the list collection that we have to the tree collection. Maybe yes, because you saw the result, but I need to do some more tests to ensure that this is the correct way. That have the, by default the R3. I didn't find all the errors, if there are any errors when you create the visualization or things like that. So I have to ensure that this is good for production. Yes, Steph.
You didn't show the possibility to change the center.
Oh yes, but you know, I talk about, okay, Steph is talking about if I didn't show that you can change the position of the origin coordinates of Roassal. Yes, that is possible because the original position in Roassal is always the center of the window. But that is something also that you can change now, that you can use top left, and instead of you have to create your own extensions to simulate things like that in Roassal. So yes, now I talked about this in the last year, but the camera has a matrix transformation. That means that you can rotate the camera, you can apply escalation, so you can change the direction of the coordinates, because yes, it's following the matrix transformation. Any other question? Okay, I think we are done. Thank you very much.